Hey everyone, welcome to Starfax's new video. Saturn, the ringed planet, a celestial wonder. It's the sixth planet from our sun. Saturn is huge. It's a gas giant way bigger than Earth. But there's something amazing about this planet. Saturn could float in water. How is this possible? This gas giant has a secret. It's all about what Saturn is made of and how this affects its density. Saturn is mostly a giant ball of gas. It's one of the most fascinating planets in our solar system. Known for its stunning rings and immense size, it doesn't have a solid surface like Earth. Instead, if you tried to land on Saturn, you would sink into its dense atmosphere. The main ingredients in this giant are hydrogen and helium. These gases make up the bulk of Saturn's mass. These are the lightest elements in the universe. They are so light that they rise above other elements, creating the vast, swirling clouds we see. Think about blowing up a balloon. When you inflate it, you're filling it with gas, just like Saturn is filled with hydrogen and helium. You use your breath, which also contains hydrogen and helium. These gases are essential to life in the universe. The balloon gets bigger, but it doesn't get that much heavier. This is because the gases inside are very light. Saturn is kind of like that balloon, just on a much larger scale. Imagine a balloon the size of a planet. This gaseous composition plays a big role in why Saturn would float on water. If there were a bathtub big enough, Saturn would bob on the surface like a giant cosmic rubber ducky. So, what determines if something floats or sinks? It's all about density. Density is how much stuff is packed into a certain space. Imagine holding a rock and a cotton ball of the same size. The rock feels heavier, right? That's because it's denser. More matter is crammed into the same space. Objects less dense than water float. Objects denser than water sink. Get ready for a splash of knowledge. Saturn's density is lower than water's density. Saturn versus water, a buoyancy battle. Here's the fact. Water has a density of 1 gram per cubic centimeter. This means that for every cubic centimeter of water, it weighs 1 gram. It's a standard measure we use to understand how dense or heavy a substance is. Saturn's average density is only about 0.69 grams per cubic centimeter. That's less than water. Imagine that, a whole planet less dense than water. This is because Saturn is made mostly of gases like hydrogen and helium, which are much lighter than the rocks and metals that make up Earth. This means if we had a giant bathtub big enough, Saturn would actually float in it. Picture a colossal bathtub in space, filled with water, and Saturn bobbing on the surface like a giant rubber duck. Now, this is just an imaginative comparison. We don't have the technology or resources to create such a massive structure. In reality, we couldn't possibly have a bathtub that big. The sheer size and scale required are beyond our current capabilities. But the idea helps us understand the concept of density and buoyancy. By comparing Saturn to water, we can grasp how different materials interact with each other in terms of floating and sinking. This simple analogy makes complex scientific principles more relatable and easier to understand. Imagine Saturn in a bathtub. Think about a giant inflatable pool toy. You blow air into it, and it floats effortlessly on the water. Saturn, with its low density, would behave similarly in our imaginary giant bathtub. It wouldn't sink to the bottom like a rock. Those majestic rings. Let's not forget Saturn's most stunning feature, its rings. These rings are not just a simple adornment, they are a complex and fascinating structure that has intrigued scientists and astronomers for centuries. These rings are made up mostly of ice and rock particles. The composition of these particles varies, with some being as small as a grain of sand, while others are as large as a house. These particles range in size from tiny grains to enormous chunks. This diversity in size creates a beautiful and intricate pattern that can be seen even from Earth with a good telescope. Even though the rings look solid, they're not. They are actually made up of countless individual particles that are constantly moving and colliding with each other. They're spread out over a vast distance. The rings extend up to 175,000 miles from the planet, yet they are incredibly thin, only about 30 feet thick in most places. This means the rings themselves also have a very low density, contributing to Saturn's overall buoyancy. The low density of the rings is one of the reasons why Saturn, despite its massive size, would float on water. So, there you have it. Saturn's rings are not just a beautiful sight, but also a marvel of nature that continues to captivate and inspire us. Saturn, despite its massive size, would float on water due to its low density. This is a fascinating fact that highlights the unique characteristics of this gas giant. It's a fascinating example of how even the largest objects in our universe can surprise us with their unique properties. The study of Saturn and its rings continues to provide valuable insights into the formation and evolution of our solar system. Thanks for watching. Subscribe this channel. Like, comment, and share this video.